tardes a todos, bienvenidos a una nueva edición del CTO Summit. Mi nombre es Alex Barrera y es un placer estar esta tarde aquí con vosotros. Tengo entendido que ayer pasasteis un día muy bueno con nuestro amigo Buenos Vinos y que todo el mundo lo pasó fenomenal. Bienvenidos a todos los que os estáis conectando. Estamos hoy emitiendo desde España para todas partes. Yo en Madrid, el equipo en Valencia, nuestra invitada en Barcelona y todos nuestros amigos que están conectados a través de Internet. Muchísimas gracias por estar hoy aquí. Y bueno, para hacer esta introducción, esta presentación al workshop, al taller que vamos a tener esta tarde, voy a cambiar temporalmente al inglés porque ya sabéis que el taller va a ser en inglés y, ante todo, educación y cortesía. Sed conscientes de que nuestra invitada de hoy habla tanto castellano como inglés, con lo cual cualquier pregunta que tengáis, cualquier duda que vayáis a tener, por favor, ponerla en castellano, ponerla en inglés, el idioma que os dé la gana. Me consta que maneja algún otro, con lo cual podéis intentar aprobar suerte. Puede que yo no lo pronuncie tan bien, no obstante, pero en inglés y en español nos manejamos. Pero recordad que podéis ir metiendo vuestras preguntas durante el taller en la plataforma de Brela y recordad que vamos a dividir el taller en dos partes. Vamos a tener una primera parte, vamos a hacer una pausa que dirían pausa técnica. Mientras tanto, ir metiendo, ir introduciendo, ir haciendo vuestras preguntas para que el equipo de realización me las pueda ir pasando y podamos en la pausa intermedia comentar estas preguntas y pasársela a nuestra invitada. Y tendremos una segunda parte y volveremos a hacer al final otra parada técnica para hacer las preguntas y despedir a nuestra invitada de esta tarde. And without further ado, I'm switching to English because our next speaker has an incredible international background. And we're going to be talking about operationalization of responsible AI, which is, by the way, one of my favorite topics because me being a computer scientist and having specialized in AI, I think it's a very, very important topic to talk about. And our speaker is going to go in depth into this space. So I'm really, really anxious and excited to have her here. She has an incredible background. She's a big data and AI expert. She's gone all over Europe, from Moscow to Riga, and now to Spain, where she's an adjunct professor for several years at the UAB in Barcelona. And most currently, she's one of the experts and senior data scientists at Microsoft. So to talk about responsible AI, I want to welcome our next speaker. Please, big virtual applause for Liana Napalkova. Hello, Liana. How are you?
Hi, Alex. Thank you very much for this wonderful introduction. And hi also, everyone. And thanks for attending this session. Actually, I'm very happy to participate in a virtual edition of CTO Summit. And I hope that you will enjoy this session and find also useful information, useful takeaways for you. And well, in this presentation, I will talk about two different topics of responsible artificial intelligence. First of all, algorithmic fairness, and then also model explainability. And the emphasis of this session will be on the algorithmic fairness. So now let me share my screen. Bear with me. Okay, so now I assume that you can see my screen. Okay, so let's start the presentation. I would like to start my presentation from discussing the rising use of digital technologies, what we can also call as digital transformation. One of the fields in the scope of digital transformation is automated algorithmic decision-making. So in some domains like e-commerce, automated algorithmic decision-making has been used for a while, right? So for example, recommender systems. But other more regulated domains are just starting the adoption of algorithmic decision-making. For example, air transportation, airlines, airports. So the digital transformation also creates new jobs. For example, social media jobs were non-existent 10 years ago. And nowadays it's a $31 billion industry approximately. In general, we can clearly see that more and more decisions in our daily lives are being controlled by artificial intelligence algorithms, okay, in domains such as personalized healthcare, banking, for example, provision of loans, education, recruitment, also dating, and so on and so forth. The reasons of why automated decision making is so popular are actually numerous, such as, for example, lack of sudden decisions, right? Low cost of artificial intelligence systems for repetitive tasks, and also algorithms do not become tired or bored like we human. So for many studies, many studies have shown that artificial intelligence systems can unintentionally inherit a lot of human biases, right? They can also generate misleading decisions. While it's clear that every one of us has certain biases, algorithms can amplify these biases. That's the point, okay? And so therefore, it's so crucial to develop artificial intelligence algorithms that are not only accurate, but also inclusive, transparent. And the wow effect of technology shouldn't be a driver in developing automated decision-making systems, okay? The research field that address those issues is called responsible artificial intelligence. And this is what we will be talking about today. So Microsoft has been very active in this field. There is a strong focus on putting the principles of responsible artificial intelligence into practice. Microsoft developed different guidelines and open source tools for responsible artificial intelligence that we will cover in this presentation. There are many internal trainings and initiatives at Microsoft, and if you want to get more details, I leave you here some links, in this slide. Okay, so as I said earlier, in this presentation, I will cover two key aspects of responsible artificial intelligence, such as algorithmic fairness and model explainability. And the key focus will be on the algorithmic fairness. So let's start from the algorithmic fairness. Initially, I will give you quite a lot of examples and also some theoretical information, and I will do it intentionally, okay? So later you will understand the reasons why actually I gave you so much let's say theoretical information. Then I will show you an interactive framework that you may use to develop fair algorithms, or you may want also to participate in the improvement of this framework because it will be open source. And at the end of this section, I'll demonstrate a use case with FairLearn. FairLearn is one it's open source Python package developed by Microsoft. Okay, so you can use it also even if you don't use Azure Cloud platform. Okay, so look at this optical illusion. Actually, I was thinking how to start this presentation, and I found this optical illusion that I think is very relevant to what I wanted to explain. So just take a look during a couple of seconds. What do you see? So probably you see some small motion, while actually the image is static in reality, right? It's not moving, it's just static. So this is because your brain created perception that in this case is not real, right? So this is just, so our brain is trolling us continuously. For example, the frequency with which people write about certain actions or events in social media is not necessarily the reflection of real world frequencies, for example, right? Okay. Often we also deal with social habits that change over time. So there are biases that reflect our real social habits at certain time period. As you may see in this slide, search results for the keyword cashier mostly include women, right? As you may see here on the left. And search results for the keyword CEO mostly include men, as you may see here on the right-hand side. And this is what we still often see in real life. It is not our illusion, it's reflection of the real world, okay? And let me actually give you one more example. Stereotypes are built on top of our social habits, and stereotypes are just simplified snapshots that may be or may not be real. So probably most of us who are technical people, we have been using Stack Overflow, right? So I just decided to make a very simple test with Stack Overflow. Actually, I used Stack Exchange Data Explorer and executed this query that you can see on this slide. I wanted to see the usage of pronouns such as she pronoun in comments that appear in Stack Overflow. And what I have seen basically is the following. I've seen that only approximately 3% of comments that use pronouns, they use pronoun she, but the rest of them use other pronouns, use pronoun he, right? And this is actually the reflection of the real life, because distribution of software development by gender, for example, here you can see most of them are men and just small percentage of women. But what I've noticed, and maybe some of you also noticed, when you ask a question in Stack Overflow, even if your nickname is female, belongs to the female gender. Even in this case, very often people use he pronoun, right? So it's like kind of stereotypic behavior. It's quite interesting, actually. So why actually I'm explaining all these things? Because if you think a little bit about stereotypes, the logical question comes to mind. When artificial intelligence system should mirror real world biases to some certain extent, and when artificial intelligence systems should mitigate these biases. So when the system should forget about stereotypes, and when the artificial intelligence system should use the stereotypes in automated decision making. That's the question. In my opinion, the answer depends on the final usage of artificial intelligence system. For example, in healthcare, the attributes such as gender or age are very likely to influence health-related behavior, for example, in case of screening procedures. And neglecting this aspect, so neglecting the gender and age of a person could, of course, be harmful, right? But in financial industry, the prediction of, for example, credit worthiness, considering gender, race, age of a person, may discriminate the minority groups. Right? Just because these minority groups appear less frequently in our historical training data that we are using to train our machine learning system. So therefore, fairness in artificial intelligence is normally considered as socio-technical challenge. It's not just a technical challenge, it's socio-technical challenge. And in the scope of automated decision making, it's very important to consider the final usage and the context of our artificial intelligence system. So let's now let me show you just some interesting examples of biases, right? You will see that in my slides in the bottom, I'm also giving the references where you can find more information about the examples that I'm using in this presentation, okay? So this is the example, what you currently see in the slide. This is the example created by researchers from Facebook AI research. In this slide, you see the pairs of images in which both persons of a pair belong to the same sport, but they differ by skin color, right? So for example, this is the first pair, this is the second pair, this is the third pair, and so on and so forth. So the first row contains photos of black persons, right? This one. And the second row, this one, contains similar photos of persons of different skin colors. And the goal was to predict the basketball class, okay? And researchers used ResNet 101 pre-trained on ImageNet in order to label these photos. As you may see, actually all photos with black persons were labeled as basketball players, okay, independently on the sport, on the type of the sport that they are practicing. So, but the persons of different skin colors are labeled differently, as you may see here in the bottom. And clearly the model has learned biased representation of the class basketball and associated the skin color with basketball class, okay? Another example, in this next example, researchers used images from in-situ dataset. This is the openly available dataset, and this is the dataset that supports situation recognition, okay? So each image is paired with a table. You can see the table below each image, right? And so the tables describe the picture, right? And this table contained the verb, cooking, then the adjunct, which means man or woman, and also other values, other features. And in this training set, in in-situ data set, 33% of cooking images have men in the adjunct role, while the rest have women, so 67%, the most of them. So basically what happened, after training a model on this data, the bias was even amplified. And in this case, men feels 16% of adjunct roles instead of initial 33 in cooking images. Right, so here you can see that, for example, this person who is a man, he was identified as woman. And the situation, because this situation relates to the cooking. So let's take a look at another example. Probably many of you have heard about generative pre-training transformer version 3, which is also called GPT-3. It was trained on a huge corpus of text from internet. Okay, this neural network has billions of weighted connections between different nodes, and basically it can generate, well, it can do different things, but it can generate a text. For example, if you provide input like she works as, then GPT-3 can complete your phrase. And it turned out that a generated text might be biased or even offensive, right? You can see some examples here on the right-hand side. And according to the head of artificial intelligence at Facebook, GPT-3 is, of course, creative and surprising, but it's also unsafe because of these harmful biases. And of course, more work on responsible AI, responsible artificial intelligence, is required before putting such systems in production environments, right? Before using them in real life, especially if we consider their lack of semantic understanding of a generated text. So I would like to show also an example of biases in speech recognition systems and which consequences these biases may produce in people's lives. Okay, because remember at the beginning I said that the impact might be even harmful. So the impact of these biases. So a few years ago, an Irish woman took English test in Pearson. Pearson is the agency that provides different tests. So, and well, she wanted to immigrate to Austria. Okay, so that's why she took the English test. So to test the speaking ability of candidates, Pearson use voice recognition technology. Okay, so it's fully automated, like automated decision making. And this Irish woman surprisingly failed spoken English proficiency test. Okay, she passed written English and other also parts of the test, but she failed a spoken English. But she was actually a native speaker of English, right? But that's just because of some certain, let's say, accents, and finally the decision was negative for this person, and it was also harmful for her life. I hope that finally this situation ended up successfully for this person, but yeah, so. And the final example that I wanted to show you is related to toxicity classification. Okay, ideally, the language systems that perform sentiment and toxicity analysis should give the scores that are independent on the identity and named entity, but it's not always the case. As you see in this slide, a phrase such as, for example, I hate Rihanna, has low toxicity score in comparison with the phrase I hate Justin Timberlake, right? And but in both cases you say I hate, just the identity changes. And similarly, the phrase the gay and lesbian film festival starts today has high toxicity score, but in fact it's a neutral phase. So social biases towards real life entities are often reflected in the language, and such biases can be passed to trained models. Okay. So I think that these examples actually explain the importance of building fair automated decision-making systems. To avoid any confusions, let's define the term fairness, okay? Because maybe we could, so all of us can interpret it in a little bit different way. So that's why let's say standardize, okay? So in the scope of this presentation, the term fairness will be considered as the relationship between sensitive attributes, such as, for example, race, gender, and the output of the model, okay? And by saying fair system, I will refer to a system that ensures that the benefits are available across all segments of society. So just out of curiosity, I used the API of Archive to find out how many articles contain the term fairness in the paper title. Okay, so because Archive has, Archive, this is the repository of different scientific articles that I think all of us know. And this repository has the API, okay? And you can use this open source API for different purposes. So in my case, I just decided to investigate how many articles contain the term fairness. And I focused on only on computer science, mathematics, and statistics editions of Archive. So as you may see, the number of articles on this topic has been growing exponentially in the last 5 years in computer science edition. And currently this is the growing field that starts getting more and more attention because more decision-making processes get automated and involve artificial intelligence. So data biases are inevitable in real world. They exist and they will exist. We must design algorithms that, depending on the context, can account for these biases, okay, can correctly treat, process these biases. Let's consider the end-to-end machine learning process that starts from data generation and ends up with the model and deployment. The first question to ask is, who will be the end user of this model? And which are the key priorities of decision makers? For example, can false negatives or false positives be harmful in this specific context? Yes or not? Then it's important to consider different sources of biases, okay, and as checkpoints during the complete end-to-end machine learning process. Because biases do not only appear in the historical training data. So we will see in the next slides that biases can actually occur at different moments during the machine learning process. So once a source of biases is identified, we can calculate fairness measures. It does not make sense, and it's even impossible to optimize a system with respect to all existing fairness metrics. The choice of fairness metric strictly depends on decision makers' priorities that I mentioned earlier. For example, are false positives more important than false negatives? So once fairness metrics are selected, the next step is to select corresponding bias detection techniques, okay? So here we use these fairness metrics that we selected on top of bias detection techniques. And finally, bias mitigation techniques can be selected depending on all previous steps. So this is how I see end-to-end process to develop fair algorithms. Now let's take a look at each of these aspects in a bit more details. So let's start from bias sources. There are many different ways to classify biases. I personally like the taxonomy proposed in this article. The article is called Framework for Understanding Unintended Consequences of Machine Learning. You can see the reference below. The authors of this article define 6 different types of biases that can appear during the end-to-end machine learning process. And These biases are marked in red color, such as historical bias, representation bias, measurement bias, aggregation, evaluation, and deployment bias. Okay, so let me just quickly introduce each of them. The first one is historical bias. It comes from existing social bias, actually. For example, some historical disproportion between males and females, right, among software engineers, and so on and so forth. The next one is representation bias, and it happens when the training data is not representative of the real world. Okay, so you have some sample with which you try to train your model, but this sample is not representative actually. Then we have measurement bias. Measurement bias means that there is a bias during the feature engineering or labeling process. For example, let's imagine the task of predicting flight delays. Instead of building a separate model per airport, you just built a model without considering different differences between airports. So then there is also aggregation bias, and finally there is also evaluation bias. Okay, so these are two, and also deployment bias. So in case of evaluation bias, it happens when when the testing data set is not representative and performance metrics are inappropriate. For example, imagine that you build time series forecasting model in gas and oil field, and then you apply this model on the time period which contains many anomalies, right, and is not representative. So in this case you may model, so basically in this case what may happen is that your model could perform poorly, right, but this evaluation result is actually biased. And deployment bias occurs when model is used or is interpreted in the wrong way. Let's take some example as well. The model was originally used to predict flight delays only in Barcelona airport, but you tried to apply it to London Heathrow airport, right? So this would be improper, like the example of the wrong usage of the model. Okay, so as I said, the link to the article is given below if you are interested in more details. So the key takeaway of this slide is that any end-to-end machine learning process may suffer from any combination of these biases. The bias is not only the question of historical bias in the raw data, but it also can occur, for example, at the last stage of the model building and implementation process, actually at the deployment stage, right? This is the most important takeaway from this slide. Now let's talk about fairness metrics. So one of the most comprehensive classifications of fairness metrics that I found was proposed in the article which is called Fairness Definitions Explained. And the link is also given below. The authors divide all fairness metrics in 3 different categories, such as statistical metrics, similarity-based metrics, and causal reasoning. The most frequently used group of metrics is statistical metrics. These are the metrics implemented in most of open source packages, and specifically the metrics based on predicted outcome and metrics based on predicted and actual outcomes. Okay, here, demographic parity, for example. Okay, now let's take a look at bias detection techniques. So The choice of proper bias detection technique depends on whether you deal with traditional machine learning or deep learning. In deep learning, the explicit feature engineering stage is neglected, omitted. Therefore, it is hard to identify bias from the input perspective. In this case, it's recommended to identify whether a protected attribute such as gender or race has been captured by the intermediate representation of a neural network, and degree to which this protected attribute contributes to the model prediction. Okay, so don't worry if you maybe miss some, let's say, insights or some of these methods. If you are unfamiliar with some of these methods, don't worry about this. That's okay, that's fine. Later on, actually, I will explain you the reason why I'm presenting all these, techniques and methods, and why I'm giving you this overview. Okay, just I will explain it a bit less. I'm doing it intentionally, actually. So the final thing that I would like to discuss, the final group of techniques related to algorithmic fairness, is called bias mitigation techniques. Okay, and again, so here we have a variety of different techniques. Debiasing techniques can be classified according to the stage at which the debiasing should be applied. These stages are dataset construction, also known as preprocessing, then model training, also known as in-processing, and inference, also known as post-processing. So very often different terms are applied to the same thing, therefore I specified these synonyms, okay? Preprocessing is aimed at debiasing a training set. In-processing is applied during model training, for example, removing information about some sensitive attributes. Right, and then finally, post-processing is performed after model training. And this is done to calibrate the predictions of the trained model, okay, so to make them fair, more fair. Okay, so as we have seen in the previous slide, there are many different debiasing techniques. One of them is shown in this slide. So many problems in computer vision unintentionally reveal some socio-demographic information in images. So, for example, in COCO dataset, this is the dataset openly available for usage. So in this dataset, images of plates contain much more women than men. And if a model predicts that a plate is in the image, we can infer that there is likely a woman as well in this picture. So this is called leakage. And a possible approach is to remove gender in images, as it is shown in this slide and proposed in the paper provided below. There's just one more approach to debiasing, which is called adversarial debiasing. So, until now, I gave you quite a lot of theoretical information, right? And as I said, I did it intentionally. So, of course, the theoretical information is not exhaustive. I mean, the overview that I did is not exhaustive. We can enter in more details. But what I wanted to do actually is to show that algorithmic fairness is quite new and quite challenging field with many open questions and sometimes a bit confusing aspects of the terminology and techniques that should be applied. And it might not be straightforward for practitioners to select proper techniques and apply them in real-world engagements. So that's why, this is the reason actually why I'd like to share the interactive framework that I started developing initially just for myself. Actually, let me explain you a little bit the story. I was working on engagement at Microsoft, and the goal of this engagement was to perform some fairness analysis and also develop the models that would be fair and also interpretable. Okay, so we will discuss interpretability in the next part of this workshop. So this was the goal. And when I started working on this task, I found out that there are many different packages, many different approaches, also overlapping terminology. And then I thought that probably it would be nice actually to have some quick starter solution, some sort of framework for those who are developing artificial intelligence systems and should apply principles of responsible artificial intelligence in practice. Because maybe some of you work in domains where automated decision-making may affect human lives. So let me actually start this video. So I made the capturing of the screen. I made the screen recording in order to show you the web application that I developed, okay? But it's available also openly. I will give you the link at the end of this presentation. So initially you have seen that I selected algorithmic fairness, okay? Because in this web application, there are two options. You can either use it for explainability analysis, or you can use it for algorithmic fairness. So now we are talking about algorithmic fairness. The first question that you should answer is, what do you want to explore? And here you have two options, data bias or model bias. So let's imagine that you have a data set that you want to use for training your model, and you just ask yourself, how should I start? Which packages, which libraries should I use? What should I do? Okay, so in this case, you should select data bias, and here in this in the next window, you can see the list of open source Python packages, and also different, let's say, metrics that are supported to measure the bias. Okay, so for example, EE.UU 360, and you can see which metrics are supported. And then also here in the sample notebooks, you can download an example for how to use this package. Okay, then if you let's go back. So let's imagine that you have the model that was already trained, and you want to either mitigate or analyze the bias. So if you select bias mitigation, you can see that there is a list of methods, of libraries, sorry, that support bias mitigation. And in the visualization of results, you can click on example, and you will see how the output will look like. Okay, so what will be the which are the widgets that are used by the open source package. So this example for the algorithmic fairness is quite short. There are much more libraries for the model explainability that I will show you later in the second part of this workshop. And also pay attention that I'm extending the list of packages in this framework. So in the future, I'm also going to add more packages in this framework. Okay. So, well, this framework that I just presented, it includes many different open source packages of different providers like IBM, Microsoft, also just some researchers, some developers who are working in the field of responsible AI. But now let's take a closer look at one of these open source packages called FairLearn. This is the package developed by Microsoft, but it's open source. And you can easily install this package, just pip install command, right? And if you want to use it with Azure machine learning service, then you should also install some additional packages, but it's completely independent on Azure. You can also use it without Azure. FairLearn provides fairness insights on model predictions, and it supports different fairness metrics such as demographic parity, equalized odds, etc. It also supports different bias mitigation techniques. With FairLearn, you can quickly add a dashboard widget into your Jupyter notebook and use this dashboard to analyze the fairness of your model. So to see how fairness works, FairLearn works, let's consider that we should develop a model that will decide if a client is eligible for automobile loan or not. And this decision should be made based on binary output of a model that says whether the customer will default the following month or not. And we will use an openly available data from UCI machine learning repository here. So this data set contains information about 30,000 clients and their credits and transactions at the Bank of Taiwan. There are 23 different variables, including socio-demographic variables. So since the data is imbalanced and there are less clients who default the following month, we will use a balanced accuracy and also area under curve as performance metrics. And just for demonstration purposes, we will create an additional synthetic variable that has a strong predictive power for female clients, but is completely informative for male clients. Okay, so let's just create this dummy variable and let's consider that it exists in our data set. And next we will apply two algorithms on this data set. The first one will be fairness unaware algorithm, okay, that just does not do anything with respect to fairness, does not try to mitigate fairness. And the second algorithm that we will use will be fairness aware algorithm, okay, so we will try to mitigate the bias. So for both scenarios, we will use the light gradient boosted machine. Okay, so let's use two fairness metrics. The first, demographic parity, means how many positive outcomes exist for males and how many for females. And if the goal is for the two groups to receive the same number of auto loans, then of course, the logical criterion would be demographic parity. And the second fairness matrix that we will use is called equalized odds. So it is more suitable probably for this use case. It identifies equal opportunities between males and females to get auto loan. So this metric checks if inside each group the proportion of positive decisions is equal, which means that it considers both true positives and false negatives. So in case of fairness unaware algorithm, if we only use performance metric to analyze the model, then the model performance looks quite good, right? It's 0.85, so it's quite satisfactory. However, if we additionally use fairness metric, in this case, it's, for example, equalized odds difference, then we can clearly see a large disparity between two groups, females and males, which means that the proportion of positive decisions to give auto loan is higher inside one of these groups. And this is what we don't want to have, right, in real life, because it might be harmful for human lives. We can also notice that some fairness metrics may be satisfied and some others might be violated. So it's very important to consider this aspect. In this example, demographic parity is satisfied, it's okay, but equalized odds is not satisfied. So that's why you as a decision maker, as developer of the fair algorithm, you should decide which fairness metric is mostly important for you, for your use case. And then in the second scenario, we used fair-learn algorithm, which is called threshold optimizer. So this algorithm finds suitable threshold for the class probabilities produced by the classifier. So in other words, it just tries to optimize the accuracy rate, considering the constraint that the equalized odds difference is 0, okay, on training data. And as you may see, the threshold optimizer algorithm reduce actually the equalized odds difference, right? However, the performance metric area under curve gets worse. So before deploying this model in practice, in production environment, it would be important to understand this change, why it happens. So why the fair algorithm is less accurate. And in our case, it is because the available features are much less informative for males than for females, okay? Yeah, so now I will show how a dashboard of fair-learn can actually help you analyzing trade-offs between performance of and fairness of models. Basically, this will be the summary of the information that we discussed. So you may see, I also did the recording. So you can see here some code, Python code. Basically, it means that you can create this widget directly in the Jupyter notebook. Okay, so just you run this code and you will see this widget. At the beginning, this is the interactive widget. So at the beginning, what you should do, you just click on Get Started. Okay, so as I'm doing now. And then you should select the sensitive feature that you want to analyze, okay? So in this case, we want to select the gender. And then remember that our example is imbalanced data set. That's why we will use balanced accuracy as performance metric. And finally, here we can see, let me stop. So here we can see two blue dots. So these dots correspond to our models. Fairness unaware model and fairness aware model, okay? So yes, so yeah, so this one is a threshold optimizer, which is fairness aware model. And this one is unmitigated, which means fairness unaware model. So you can see that this one, fairness unaware model, has a bigger balanced accuracy, right? So it's more accurate, but it discriminates towards the gender, right? Because we see higher disparity in balanced accuracy. So now what you can do, you can click on each of these dots, and FairLearn will show you the justification, will show you more insights about each of these models. Okay, so for example, we remember that we are talking about gender. So we have two groups, female and male, and you can see that our model, which does not take into account the fairness, actually it's more accurate for female, right? And less accurate for male. And also here you can see under predictions and over predictions. And in the same way, here you can see the disparity in predictions. So, and in this way you can analyze the model. And then if we go back, we can also select the second model, threshold optimizer, which is trying to mitigate bias. And you can, as you can see, the balanced accuracy is equal, almost equal for female and for male. Yes, it reduced. So probably we need to investigate our features and understand how we can increase the accuracy, okay? But at least we can see that they are the same for both groups of gender. Okay, so now actually by this, we finished the first topic. Alex, would you like to jump in and maybe,
yeah. First of all, congratulate you because it was fantastic. I really enjoyed it. Again, I'm biased because I actually do like this topic very much. No, but it was fascinating. I think, as you pointed out, it's a really nascent field. There's a lot of angles, a lot of things to take into account. But I think you did a fantastic job covering a lot of ground base. I'm gonna be honest. I actually downloaded one of the papers you mentioned because it was like, oh, this is so interesting. So I have it over there on one of my tabs to check it later. We do have one question. I had one question personally, but I'm gonna prioritize one of the questions that we had from the audience. Let me put it here. There we go. So. Well, first of all, I hope that everyone enjoyed it as much as I did. And I'm pretty sure Liana also did, because I could see that you were having a lot of fun. Oh, yeah. They are asking me, please, if you can stop sharing the screen so we can focus on our faces. And we have this. There we go. We have this question from Fernando Calatayud. He's the CTO of Rankia, and a really cool question. He says, and I'm quoting, I don't know if men defaults auto loans more or less than women. So let me ask with a different example. We all know that women live more than men in average. So insurance companies charge more to women's life insurance. How does this fit with fairness algorithms? So all yours.
That's yes, that's actually a very nice question, because I think that this refers to the initial, let's say, to the framework that I initially, presented, the diagram. So in my opinion, the decision makers who are developing the models, they should prioritize, they should select which fairness metrics should be used, if they should be used, because it does not mean that for any model we should apply fairness analysis, right? So it depends on the use case. And then I would say it in this way. So the decision how so in which case we should apply the fairness analysis, and how we should apply fair learn strictly depends on decision maker. Then fair learn, as well as other open source tools, these are just the tools in our hands, right? Fair learn provide different types of fairness metrics, of bias mitigation techniques, but how you interpret them, how you combine them for your specific use case, it depends on the decision maker, right? So in some cases, for example, in healthcare, it might be important actually to mimic the bias related to the gender, to the age, because it may contain very important information for decision making, right? But in some other fields, like for example, finance, taking into account the gender and age may actually be very harmful for people. So that's why, in order to answer your questions, I would say that it's important to be a subject matter expert and, you know, make this decision based from the subject matter expertise, how you will use the tools.
Well, it brings up a question that I honestly was having while I was listening to your talk, which is, we're kind of pushing the problem from the algorithm design, training, data set, all the way to this decision-making metrics at the end of what algorithm do you use to, what metric do you use for the fairness. And in the end, the bias is something that kind of changes with age. I mean, as years go by, the bias that human society have keep changing, right? And
yes, absolutely.
So I wonder, because you said that this package is open source, right? So I'm guessing there's a community behind that. And I keep wondering, how are you guys dealing with that? Because then the community that deals with the open source package, in a way, is also influencing what kind of bias control or fairness control gets baked into the package. So how are you working? How are you trying to bring more people to the discussion, to maintaining the package, to engaging with the package?
So I absolutely agree, of course, that biases, for example, are changing over time, right? But also we should remember that the topic of algorithmic fairness, for example, is very recent. In one of the previous slides, I showed that in the last, basically only in the last 5 years, there was such huge increase in the research related to algorithmic fairness, right? And this is when people started actually paying more and more attention to this topic, because previously it was not that important, because artificial intelligence systems were not used at scale in so many fields, or maybe they were just used in e-commerce, for example, right? So that's why I think that the field of responsible AI is only starting to grow, and that's very perfect time to join this field. At Microsoft, we have different initiatives, internal initiatives, actually how to, in general, independent on the machine learning. We are also having some initiatives related to how to be fair inside the company, when we make some, judgment or whatever. So talking about the open source community, currently there is no standardized procedure how to decide when the bias, let's say, how to make the link between the bias evolution and the type of bias mitigation, bias metrics, right? So these kind of things. There is no link, just because this field is very new, right? But this is, I think, in my opinion, very, I completely agree that this is something to consider, right? But finally, we should remember that algorithmic fairness and, in general, responsible AI is socio-technical field. It's not technical field, and from the technical perspective, we just have tools. We just have different, pieces of code, but how we use, how we interpret these metrics, mitigation techniques, bias detection techniques, this depends on us. And this is what is evolving, actually. Maybe the same technique can be used for different purposes. Like I showed in case of so in the last use case that I showed regarding the auto loan, right? I showed two fairness metrics, and one of them was satisfied, and another one was not satisfied. And then it depends on decision maker which of these metrics take into account. Okay.
Yeah. No, it's I love the definition you gave. Like, it's a socio-technical problem, and I guess you're in an interesting situation because, as you said, this is so nascent that there was nothing. Like, I wouldn't even say 5 years ago. Like, literally, I've seen these systems start to come up this year and beginning of last year. There wasn't any technical deployment. There was a theory and there was starting to be research, but there wasn't any framework and anything tangible from a technical perspective that you could use at scale. So you are kind of paying for all this criticism that's coming around because you very rightly said, right? We're starting and we have to start somewhere. But that was definitely fascinating. I have so many questions. I could stay with you here asking questions, but I believe we do need to move forward for the second part of the workshop. So I'm going to disappear again. The floor is yours, and people keep enjoying.
Yes, thank you, Alex. Actually, let's see how, well, the second part is shorter than the first one, as I said. And so we can address more questions at the end. So please don't be shy and ask your questions. And so now I will share my screen again. Just wait a second. And we will start talking about the model explainability, okay? So, yeah, so actually, I will give you some more interesting examples in this model explainability, and then I think we will have the complete picture of responsible artificial intelligence, because so far we only discussed algorithmic fairness. So let's start from sorting out the terminology aspects. What is the difference between the terms explainability and interpretability? Because sometimes in the literature you can see two of these terms. So in this presentation, I will consider that the explainability refers to black box models, and the explainable analysis is performed on top of black box models that are too complicated for any human to comprehend. And then interpretability refers to glass box models that can be directly inspected and interpreted by human experts. Okay, so this is the difference. And I will also use the term interpretation that will refer to the understanding of predictions of both types of models. And finally, I will use the term explainable artificial intelligence, referring to the overall research field. Okay. So again, I used API of Archive to see the number of papers with the term model interpretability and explainable artificial intelligence in titles. And again, we see the rapid growth of relevant articles in the last few years. But still, the topic of interpretability, explainability was discussed a bit during a bit longer time than algorithmic fairness. Algorithmic fairness is really quite new. So why do we need explainable artificial intelligence? So when working with real-life use cases, it's important to understand the reasons of model decisions and how input data is used by a model to make predictions in order to ensure that the model use correct features, and it is compliant with regulations, and it is not biased. So let's consider the end-to-end machine learning process that starts from data generation and ends with model deployment. The outcome of this process is the model deployed in the production environment in order to automate the decision making. So this model generates predictions that are covered, that basically are transformed in decisions, right? And then these decisions may have certain impact on business KPIs, customer service level, perception of brand of a company, etc. So if the model builds its predictions based on some irrelevant features, while decision makers are confident in this model, then there is a risk of amplifying the impact of harmful decisions on business and also on users. And in some domains, such as aviation or healthcare, the lack of model understanding can be even dangerous for human lives. And we will see it in a couple of examples. So the good illustrative example is predictive maintenance in aviation. I'm a fan of air transportation, of aviation, so that's why I just really wanted to make some example related to this field. So the idea of predictive maintenance is to predict the equipment failures before they happen. Okay, so that's why it's called predictive maintenance. Theoretically, nowadays, a lot of data is available for predictive maintenance. For example, Airbus 350 contains 50,000 approximately sensors on board and can collect more than 2 terabytes of data every day. So a huge amount of data. But to put predictive maintenance models in practice, the models that will use these terabytes of data, the stakeholders must be sure that the model, predictive maintenance model, is reliable. Why? Because the cost of taking airplane out of operations for maintenance due to just wrong prediction of potential failure of the airplane, so this cost is very high. Okay, let's imagine that model says, oh, there is a risk of failure with this airplane, so let's take out the airplane of operations for maintenance. But in reality, it's not the case. So the cost is very, very high. And there is a need for really low false positives and a meaningful interpretation of how certain prediction is made. Okay. Another example is fraud detection system of Scandinavian Airlines. The goal of this system is to detect fraud in Eurobonus loyalty program. However, the tricky aspect is that the fraud detection system should avoid accusing wrong persons of fraud. Because they are valuable users of the Eurobonus loyalty program. And the fraud detection system of Scandinavian Airlines was built on top of Azure cloud platform of Microsoft, and data scientists of Scandinavian Airlines used Microsoft technologies, including open source InterpretML package, to verify model predictions and produce explanations about model behavior. Then probably many of you have seen this example. It's just classical example related to explainable AI. So back in 2016, researchers from Microsoft presented technique to explain the prediction of computer vision model. And this computer vision model was trained to classify objects in photos. Okay, so to demonstrate the technique, researchers decided to do social experiment. They just trained a model to predict wolf when photo contains snow background. Okay, so like you can see here, in many photos of wolves, actually the background is snow. And then in case of husky, there was no snow in the background, and this was done intentionally. Okay, so they intentionally actually did this. Okay, so then researchers applied the trained model to photos of wolves, mostly in snowy backgrounds, and huskies mostly without snow. So the accuracy of predicting wolves and huskies was of course high. So finally, researchers showed these results to machine learning experts and asked two questions. Do you trust the model? And do you understand how this model is making predictions? And many of machine learning experts said that they trusted the model. Okay, so it was back in 2016, as I said. So they said, yes, the model is reliable. Yes, we trust. But when these machine learning experts saw the explanations, right? So you can see an example of the explanation here on the right. They understood that the model was basically looking at the background rather than animal. Okay, so even the machine learning experts were fooled by bad model. So here you can see that this is the husky, right? And it was classified as wolf by the model. And then on the right-hand side, you can see the explanation of this classification, and you can see the explanation includes snow. So basically the model just used the background to justify that this is wolf. And it does not look at the animal at all. So that's why actually explainable AI is so much important. And I was saying that before putting models in the production environment, it's really important to understand how the model is making predictions and which features the model is using. So now let me show you actually the second part of the interactive framework. So now we will go to the explainability analysis, and you can see that this interactive framework asks you the first question: what is the type of your data? Okay, so let's imagine that you are working on, so you are developing the model, and you want to be sure that your model is not the black box. Okay, so you don't want to use image background for predicting objects on the photo, right? So then the framework asks you at the beginning, what is the type of your data? Tabular data, images, or text or documents? So for example, you select, I have tabular data. I'm building my model on the tabular data. The next question, what is your machine learning task? So what are you trying to solve? Regression, classification, or forecasting? So let's imagine that you select classification. You are solving the classification problem. And here it gives you different options. Let's imagine that you are building deep learning model. Again, the framework gives you a list of available open source packages in Python. And also you can see what are the recommended explainers that you can use for deep learning for the classification case, having the tabular data, not images, not text, but tabular data, right? So what is the supported input data format? What are the supported frameworks? So for example, if you use PyTorch, then not all packages may support your framework, right? So Then you can also on the right hand side see examples how the explanation, the interpretation will look like. Okay, so you can see that different open source packages provide different widgets. Okay, so this is the framework that you can use when you work on your project and you need to interpret your model, because as I said before, there is really huge variability of different tools, and sometimes it might be really challenging to select a suitable package for your specific case. And now here you see, for example, the techniques, deep learning techniques for images for classification task. And you can see how different packages, so how the interpretation look like in case of different packages. Okay. Okay, perfect. So if you will have some questions on this framework, then we can discuss them later on. Okay, so now I will quickly introduce you the Interpret ML. Just to finish this workshop. Interpret ML is open source Python package developed at Microsoft, and there is also a separate package called Interpret Text that supports the explainability in text analytics. So Interpret ML includes glass box models, such as, for example, explainable boosting machine that can be actually quite accurate and at the same time interpretable by human expert. And moreover, Interpret ML supports different post-modeling explainers, such as Lime, Sharp, and others to explain existing black box models. The most important thing is that it includes interactive plots that can be integrated into Jupyter Notebook by data scientists and extracted as HTML reports. And these HTML reports can be used by non-technical people to, like by business people to understand how the model makes predictions. In this slide, I show you one of the dashboards of Interpret ML. Actually, it's dashboard of Interpret community that extends the initial Interpret repository. Interpret ML dashboards allow you analyzing the model performance per each group of values of each feature. These are called cohorts. So here you can see age, for example, the feature which is called age, and it was divided in 3 different cohorts, such as age lower or equal to 35 years, age larger than 35, age, yes, and also all data, okay, just without splitting. And then you can see that in the dashboards, actually you have different options. You have model performance, dataset explorer, and also aggregate feature importance and individual feature importance and what if analysis. And you can use this this interactive widget in order to play with your model and understand how it behaves, right? So, for example, here you can see that for different, actually aggregated feature importance is slightly different depending if the age of a person is lower than 35 years or larger than 35 years, right? So this might be something that you may want to pay attention to. And this is just one more example of from the widget, which refers to model performance. Here you can see how the model performs for different groups of ages, right? So it gives you a lot of really flexibility. You can play a lot with the model that you have trained before putting this model into the production environment. Yes, and so the final example that I'm going to show in this workshop is the example of interpret text. So this is the sample dashboard generated by interpret text, and it can work with BERT, recursive neural networks, and etc., and other models. For example, below you see the sentence, and on the right-hand side you can see how this sentence was labeled. So it was labeled as government, right? Then the dashboard shows you a list of words that were used by model to come to the conclusion that it's related to government. And as you may see, these words are affected, installation, unit, and term, right? And also you may see that the term affected has the highest importance, right? So this is basically like the main words, word that, let's say, the top words that justify why the model decided to label this sentence as government, right? And also here on the right-hand side, you can see positive features importance and also negative feature importance. What does it mean? If the word is marked if it's highlighted in blue color, then it means that this is the word that justifies the prediction of the label. But negative feature importance would mean the word that goes against the label, okay? But currently in this example, we don't have such words. So you may actually decide yourself if this label government is correct for this sentence or not. It depends probably on your use case, okay? Perfect. So key takeaways. So these are key takeaways from today's presentation. First of all, I would like to highlight that the automated decision-making systems must support the principles of responsible AI, because otherwise they can just amplify human biases, those human biases that might be harmful for people. So that's why we must be really careful with deploying the models in the production environment. And then the next takeaway, if we do not fully understand how the model makes predictions, then such model can be potentially harmful for our business and also for the society. And this is what we have seen in the example with the predictive maintenance for the airplanes, right? Actually what we have seen also with the prediction of wolves and huskies on images. Right? So basically the model was not using the correct features. And if we would use this model in some system, real world system for making important decisions, then at some moment, of course, these decisions would be completely meaningless. There are many different open source tools to perform fairness analysis and also to analyze model explainability. And the interactive framework that I'm working on and that I presented in this workshop can be helpful in selecting the most appropriate open source tool for your task, okay? And the final takeaway that I would like to highlight is that Microsoft has open source tools such as FairLearn, InterpretML that you can use in your projects even without using Azure Cloud Platform. But of course, they are also supported in Azure. And I highly recommend you actually to take a look at these two packages if they are relevant, to your to the problems that you are solving in your companies. Here I give you the links of FairLearn and InterpretML, but you can also easily find them on internet. And finally, I also give you give you my contact details in case you have some questions, suggestions, or complaints regarding the interactive framework that I presented. Please pay attention that this framework is not the product of Microsoft. I mean, the video recording, the screen recording that I was showing of the web application for selecting the proper package for your use case, this is not the product of Microsoft. This is just my own initiative that was born after doing some projects on responsible AI. So that's why any complaint or recommendation or whatever you may have, just feel free to address these questions to me. Okay.
Okay.
And thank you very much for your...
No, if you want to say, if you don't mind, stop sharing the screen, because I believe if you still share, I don't appear on screen. There you go. I don't know, for me, I caught you in the middle, but if you want to say some final words.
No. Actually, you actually cut me in the right moment, because this was the right moment. Yes.
Okay, no, first of all, thank you so much. It was really, really interesting. I personally enjoyed it a lot. And I believe, let me check. Okay, they're congratulating you on your talk on the Brella chat. So I'm
thank you very much.
Forwarding that to you, so you know it. I personally had a question, because I think the as you pointed out, the framework you created, you personally, I think is really useful. As someone that, even though I do this kind of shows, I'm still a coder, I'm still a developer, and I pretty much like this field where and actively code on certain areas. And as a developer, it's always hard when you have 15 different libraries, as you said,
right,
picking up which one. And I don't know if it's just me, but sometimes, especially when you work for a company or a startup or an organization, you sometimes try and use the ones that have better support, better manuals, better things like that. So I would like to know, well, first of all, thank you for building the framework. And the question I had is, how do you intend on evolving that? Because I think it could be very interesting to add different things like documentation, tutorials. How many tutorials do they have? What's the activity on the GitHub repository for these libraries? Stuff like that. So, what do you envision for the
exactly. So this is the perfect question. So this framework was developed using JavaScript, right, and using D3.js library. And as you may understand, it's so I should develop the additional mechanism in order to add new libraries automatically to this framework, because currently it should be done from the code. And also, as you may understand, and as you mentioned, actually this field, the field of responsible AI, is evolving very, very rapidly, and more new tools appear, right? So that's why this kind of interactive frameworks that I presented, it should be updated constantly, and more tools should be added, and maybe some of them should be deprecated. So that's why, for me, this is the top priority now, to introduce the mechanism to add new packages in the automated way, so that it would not be necessary to change a lot of the code, and this could be done by anybody. So just like anybody could, who developed the new package, could just send like request, right? Just a standardized request, and then after the revision, this package will be automatically added into the framework. And the idea is to build the global library that would just help the community to work on projects.
Yeah, that's fantastic. I mean, if it's extensible and people can add new things, especially I think the criteria that most developers use or data scientists use to select this library versus that library, like how do I put this? The efficiency of the library is one indicator, but there are others also. So
exactly. Actually, what often happens is that And it also happens to me sometimes that when you are short on time, when you should do some engagement very, very quickly, finally you end up selecting the packages that you know much better, right? Because you just don't have time for this analysis of the field, right? That is evolving all the time. So this is one of the use cases actually for using this interactive framework, because it should help it should help with the quick onboarding. So, hey, okay, I'm currently solving the classification problem. I'm working with images and I'm developing deep learning models. So what should I do? Which packages do I need to use if I want to interpret my model, right? So, yeah.
Yeah. So I'm going to close this fantastic workshop. Once again, thank you so much. With one final question for you. If you had a magic wand, what would you like? What would you wish for in this field? What would for you be that thing that, hey, that would be fantastic if we had that? So what would that be?
For this specific field, for responsible AI?
Yep. Yeah. Well, responsible or fairness, you choose. I mean, responsible AI, both sides, whatever you feel.
Oh, that's that's really a challenging question. So, yeah, well, probably I would really appreciate, and this is what currently does not exist, but maybe I would appreciate to have really some, some automated way to bring me to the solution. For example, when I start my project and I need to develop the FAIR model, so I need to fit the fairness requirements, then in this case, actually, I would like to have the access to some magical tool that would be able to say, hey, you should do this, and that. And then finally, you will get a perfectly fair model, or maybe your model is totally interpretable. It will not give you problems with your business. Like it will not crush your business, like in case of predictive maintenance, I was saying, right? So currently all these analytical processes are sometimes very long still and a bit uncertain. So I would like to have some magical tools that would, make this process shorter. And I'm sure that this will be done actually in the future.
What you need is a sociologist AI that helps you.
Yes, exactly.
Okay, well, I believe that was all for this afternoon. Liana, once again, it was our pleasure. People really enjoyed it. Very good feedback on the chat. So you did a fantastic job. And we hope we have you another time, because I want to hear what keeps coming up. This is one of my passions, this field. So really, really interesting.
Thank you very much.
I'm going to switch to Spanish. So, de nuevo, muchísimas gracias, Liana. Muchísimas gracias a todos los que habéis estado hoy aquí conectados, que ha habido bastante gente. Me han chivado por ahí los números y la verdad es que muchas gracias a todos los que habéis estado conectados. Espero que os haya gustado. Y bueno, recordar que mañana empezamos ya los keynotes propiamente dicho. Empezamos por la tarde después de comer y allí me veréis. Y espero que Liana también esté ahí conectada viéndose a todos.
Muchas gracias, perfecto. Hasta luego.
Perfecto, muchas gracias, Liana. Muchas gracias a todos y nos vemos mañana.
Hasta luego.